Okay, so let's try this one out here. We got a store manager has been selected for four, or has to select four possible applicants for two different positions. Now, this is very key. When you have two different positions, order matters. Like you're going to select the first position. The first position might be the coveted one, like the bathroom washer. Who knows, right? So he closes his eyes and he picks one person to be the bathroom washer, and the next person has to be the vomit cleaner or something. Then he closes his eyes and he picks that person. But order matters. The first person he picked is that first position, and the second person he picked has to be the second position. So how many ways can he fill the positions? Now, this one's not too hard to do because you only have two positions to fill, right? And you have four possible applicants, though. So how many people say maybe he just has these applicants in front of him. He's like looking at these things. He's saying, okay, who could be this? And he just picks one at random. There was four outcomes of that. Now, because he's picked that person, he's put him aside, and then he's going to pick the next one. There's only three outcomes for that. And there's only 12 possible ways you can fill the positions. That's almost small enough that you can actually do it. So I could say Bob, John, Mary, and Susie. And then I could just say John and Mary, Mary, John. Okay, John and Susie, Susie and John. Okay. What other ways do I have here? Oh yeah, John and Bob and John. Okay, it's 1, 2, 3, 4, 5, 6. Okay, this seems pretty good, but John's in all of these, so we're missing a few other ones. We got M and S, S and M. Okay, and then what else do we have here? So should only be 12, right? What else are we missing? We're missing the combo of M and B and M. What's our last one? Mary is in 6 of these. Bob, I'm missing a Bob. And Susie. And then Susie and Bob. There we go. That's all of them. Yep. There's no more other combinations I can do there. It seems like there's going to be more, but if you look at the kind of pattern, 1, 2, 3, 4, 5, 6. John's in 1, 2, 3, 4, 6 of them. Susie is in 6 of them. Mary's in 6 of them, or whoever M was again. And then Bob was in 6. Yeah, worked out. Cool. How many 3-digit numbers can be made using 1, 2, 3, 4, 5? Now, the key to this is just watch out for the wording. Numbers. How many 3-digit numbers can I make? Now, 3 different combinations could be a little bit different. Like you think about combination of the lock. And the combination of lock, you could start with a 0, right? But if you have a number can't start with a 0. If it starts with a 0, it's no longer a 3-digit number. It becomes a 2-digit number all of a sudden. So like the number 12 is not written 0, 12. It's just written 12. As soon as you put a 0 in the front, it becomes a different number of digits. So when we talk about numbers, you just can't put a 0 in the front, but we're not including 0, so that's okay. Repetition of the digits is not allowed. Okay, so I can't have 1, 1, 1, 1. 1, 1, 1. Okay, there's only 3 digits. Right, so order matters here because a number that starts with the 1 is going to be different than a number that starts with 2, that starts with a 3, that starts with a 4. So let's start off with the first number. I have 2. Okay, so we have 1, 2, 3, 4, 5. Then we have 4, and then we have 3 because the order matters, and I can't repeat my digits. And this is the way we're going to have to do it. 20 times 3 is 60. So 60 numbers. Okay, that's a little bit more than I want to write out. I don't want to write out all 60 numbers. Let's do it again. This time, we're going to put some restrictions on here, a little bit more than just the not allowed to be repeated. Okay, so let's consider the numbers 2, 3, 5, 6, 7, and 9. That's 6 numbers again. How many 3-digit numbers can be formed? Okay, so that's exactly the same as the previous one, right? Repetition is not allowed. We had 6 numbers before too. Well, we only had 5 numbers. This time we have 6 numbers. Okay, so this is going to be a 3-digit number, but we have 6 numbers to play with, 6, 5, and 4. So that's 120 numbers. All right, so that's just 20 times 6. Cool. Okay. How many of these numbers, there's 120 numbers in total, how many of these numbers are less than 400? So this is going to add an extra restriction here. So we have our 3 digits again, but there's a restriction. It had to be less than 400 numbers. So a number that starts with a 5, 532. Okay, that's not a number that's less than 400. A number that's less than 400 has to start with a number less than 4. So I only have a choice of 2 or 3. So I have 2 choices here. That's it, 3. So when I'm looking at to fill that position, maybe I close my eyes and I pull the numbers out. There's only 2 options I have there, 2 outcomes I can have. Now, this could be a 2 or a 3 to be a number less than 400. Now, the other numbers, it could be whatever they want. As long as that first number is a 2 or a 3, I can have a 9 in the next number. I could put it, if I pick a 2, I could put a 3 in the next spot too. Like I'm not limited after that point. So how many numbers do I have left over? I would have 5 and 4. That's 20 times 2. So only 40 of these numbers are going to be less than 400. If I want to figure out what's greater than or equal to 400, 120 minus 40, right? So I don't have to do I could do this operation too. Again, it's not too hard to do, but I can just go 120 minus 40 to find the other numbers. Let's ignore, as we go down here, let's just kind of reset. So of these numbers, how many of the total numbers are even? So I don't care if it's less than 400 now. I just want to know if it's even. So to be even, the last digit has to end off with an even number. That just defines what an even number is. The last number, to be even, has to be divisible by 2 as well. So the last number has to be even. You look at the top here, 2, 6, that's it. 3, 5, 7, and 9 are odd numbers. I only have 2 of those. And as long as it ends with a 2 or a 6, it doesn't matter what the numbers start off. It could be 956. It could be 962, right? So I can have whatever numbers in the other spots. So this would be 5, and this would be 4. So there'd be 40 numbers again, which makes sense. There's less even numbers than odd numbers. How many of them are multiples of 5? So to be a multiple of 5, it's got to end with either a 5 or a 0. It's got to be divisible by 5. So the last number has to be 5 over 0. And there's only one of those 2 numbers. This just has to be a 5, right? I don't have any other numbers here. This would be we'll write this down, 2 or 6. So I only have one choice there. I can't scroll down because I want to see the numbers. Okay, so I put a 5 there. Then we have 5 and 4. So there's only 20 numbers of all the possible numbers I have here that are divisible. So technically, it just makes sense because that's 1/6 of all the numbers. It's just this number divided by 6. Cool. If repetition is permitted, how many 3-digit numbers can I actually have? So I'm allowed to repeat now. So I got the 3 numbers again. I have 6 numbers to choose from. There's no other restrictions here. It doesn't say anything about less than that or even, blah, blah, blah. So I have 6 numbers, 6 numbers, 6 numbers, whatever that ends up being. 6 cubed. So 216 numbers in total. So I can have like a 999 or a 112 or a 121, right? So that's allowed here. So this uses all the numbers. Cool. So our next video, we're going to be talking about permutation notation. And we're at the very beginning, we talked about factorials. How do we solve factorials or problems that have factorials that are larger than, say, 100 or something. 100 factorial is too big for your calculator. If my problem involves that, I could use what we're going to do here to kind of help me simplify that down and kind of solve that. Okay? We'll talk about this factorial notation in a bit too. Like, where does this formula come from? All right, I just give you a formula, but I'll talk about that next video. Getting ahead of myself here. I'll see you then.